Welcome, Calc students. Today we have a three-part problem. Our question today is, rate at which water flows out of a pipe in gallons per hour is given by a differentiable function, r, of time t. The table above shows the rate as measured every 3 hours for a 24-hour period. This is our chart.
So let's now start with letter A. The question says, use a midpoint Riemann sum with 4 subdivisions of equal length to approximate the integral 0 to 24 rt dt. Using correct units, explain the meaning of your answer in terms of water flow. 0 to 24 rt dt. So first what you have to do is you have to solve for delta x. And in order to solve for delta x, you go back to your chart. So you take the last value minus the first value, since in your integral it's from 0 to 24. So you'll do 24 minus 0. And because it says 4 subdivisions, you divide that over 4. And 24 over 4 is 6. So therefore, your delta x is 6. So after that, since it's from 0 to 24, and you have 4 subdivisions, you start with 24, and you start with 0, and then you add your delta x. So 0 plus 6, and you get 6. Then you take this and you add 6 again, so 6 plus 6 is equal to 12. And then 12 plus 6 is equal to 18, and 18 plus 6 is equal to 24. So what you'll do is you'll take the first and the last term in each row. So 0 and 6, 6 and 12, 12 and 18, and 18 and 24. And what you'll do is that you'll add these terms and divide it by 2, since you're finding 0 plus 6 over 2 is equal to 3. Then the next row, you'll get 6 plus 12 over 2. Well, 6 plus 12 is 18 over 2 is 9. Then the next row, you'll get 12 plus 18 over 2. And 12 plus 18 is 30. 30 divided by 2 is 15. And your last term would be 18 plus 6 over 2. And that will give you 21. And you're stopping at 4 since you only asked for 4 subdivisions. Now you go back to the chart from here and you correspond each of the numbers you got and see what number that matches with. So you got 3, 9, 15, and 21. So you go back into your chart and 3 corresponds with 10.4. I'm going to draw an arrow here. You need 10.4. 9 corresponds with 11.2. And 15 corresponds with 11.3. And 21 corresponds with 10.2. So what you'll do is you'll add up all these numbers together. So multiply by delta x. And 43.1 times 6 will give you 258.6, and your units will be gallons. So far we've answered the first question where you have to approximate the gallons. So now we have to answer the second part of the question, which was explain what the integral of 0 to 24 rt dt means in terms of the water flow. So I'm going to put a little space over here to explain that. And the integral of 0 to 24 rt, in order to explain it in terms of the problem, it equals the rate at which water flows out of the pipe in gallons, don't forget the gallons, from time, which is t equals 0 hours, to t equals 24 hours. And I'm going to label this one B. And I'm going to go back and label this first part right here A. So now you've answered both questions. So now you know how to do the midpoint Riemann sum. Now we shall move on.
So letter B's question is there sometime t 0 is less than t and t is less than 24 such that r prime of t is equal to 0? Justify. We'll start off r prime of t. R prime of t is just like the slope. And when you're finding the slope, the equation is y2 minus y1 over x2 minus x1. For this case, our r2 and our y2 and y1 would be 24, 0, and 24. So r of 24 minus r of 0 over 24 minus 0. And we'll go back to the graph, to the chart, and r of 24 is 9.6, and r of 0 is 9.6. So we'll sub that back in. 9.6. Which is equal to 0 over 24. And 0 over 24 is 0. So r prime of t does equal 0. So in order for us to justify, we have to make the following statement. Since r24 is equal to r of 0, therefore, by MVT, which is the mean value theorem, there exists r prime of t is equal to 0. Now let's go to letter C.
Problem C. The rate of water flow RT can be approximated by Q of t equals 1 over 79 times 768 plus 23t minus t squared. Use Q of t to approximate the average rate of water flow during the 24-hour time period. Indicate units of measurement. So for this problem, since you're looking for the average rate of water over a 24-hour time period, you're immediately going to have to write 1 over 24. Then you set up your integral. And with any integral, you have two limits that you need. The highest limit is going to go on top, and the lowest one is going to go on the bottom. Since on the chart, it starts at 0 and ends at 24, and those are going to be the two limits. So you're going to have 24 to 0. Next, you're going to put in Q of t, which is this equation. So you're going to have 1 over 79 times 768 plus 23t minus t. And don't forget the dt. To make this problem a whole lot simpler to solve, you need to distribute 1 over 79 to each one of these numbers. So then you end up with 768 over 79 plus 23 t over 79 minus t squared over 79. Because all you did was distribute 1 over 79, you still need to integrate. And then you begin to integrate. So you are left with 768 over 79 t plus 23 t squared 79 times 2. The reason why we have times 2 is because if you look back right here, is t over 1 basically. And to integrate, you have to add to the exponent. When you add 1, you also have to multiply that exponent by the bottom. Minus t cubed over 79 times. Now, once you have your integration done, then you can start to sub the limits into the integration. And don't forget, you still need the 1 over 24. So first to sub in 24 as t. So you have 768 over 79 times 24 plus 23 times 24 squared over 79 times 2 minus 24 cubed over 79 times 3. All of this must be subtracted by the t equals 0, which is when we substitute 0 in for t. Then you'll have, over here is 768 over 79 times 0 plus 23 times 0 squared all over 79 times 2 minus 0 cubed over 79 times 3. Since everything you multiply by 0 is going to give you 0, so really you don't have to focus on this at all. And all you're left with is this. Now to break it down into what everything will equal, $768 over 79 times 24 will be 2,333 minus 58.329. Now once you add and subtract this whole, all these numbers, and once you multiply by 1 over 24, you then get 10.78 gallons per hour.